Okay, this is day 6, quiz 1. This is one of the 2 samples that I'm going to give you from the first half of this lesson. Okay, so we're going to do this particular one together. Okay, the probabilities that a customer selects 1, 2, 3, or 4 items at a convenience store is those respectively. Find the expected number of items that a randomly selected customer will select from the store. Piece of cake. First thing I'm going to do is I'm going to draw a chart. Okay. I'm going to put 1, 2, 3, 4, and 5. That is labeled X. And then here I'm going to put the probability of X happening, and the problem says it's respectively. So I will fill those in. All right, and now I'm simply going to multiply these out. 1 times 0.32 plus 2 times 0.12 plus 3 times 0.23 plus 4 times 0.18 plus 5 times 0.15. And the answer is 2.72. Now I realize that you can never buy 2.72 items from a store, but it does represent the average. You also can't have 2.5 kids in your family, but it's the average, okay? All right. Next thing, find the standard deviation. This is that super long, aggravating formula. So I'm going to put it in the same spot there, finding the standard deviation of this. Remember, the standard deviation is the typical distance all observations are from the mean. So how far are we away from 2.72 on average? Let's find out. Okay, I'm going to fill this whole board up with this giant standard deviation symbol. And then I'm going to do 1 minus 2.72 squared times its probability of happening, okay, plus 2 minus 2.72 squared times its probability of happening, plus 3 minus 2.72 squared times its chance of occurring, plus 4 minus 2.72 squared times its probability of happening, plus 5 minus 2.72 squared times its chance of happening, and then I'll square root that, okay? And that comes out 1.45. So while the average number of items you buy from a convenience store is 2.72, all of which are toilet paper at this point, the standard deviation is 1.45, okay? So that's the standard deviation. Now the last question is pretty easy. Let me erase this. The last question is, what is the probability that the next 2 customers will buy 5 items each? Consider the 2 customers independent. That question has happened on the AP test at least once. That is simply 0.15 squared. That's that happening back to back, and they're considered independent with a large sample size. Okay, so that's a quiz for section 7.1, which is the discrete random variable section. Hope that helps. Okay, this is your support video for section 7.2. This is one of the quizzes I have on the notes. And this is the continuous random variables and combining them. Okay, so again, this should be a review. We did this already, so we should be set to go. Okay, so we got a guy bowling. His name's Fat, my man Fat, and his average bowling score is 200. He's a pro with the standard deviation of 20. Meaning it's not uncommon for him to score between 180 and 220, right? The mean bowling score for Jose is 190 with a standard deviation of 15. And consider them to be both normally distributed. Okay, bowling, high score wins. Don't forget that. It's not golf, something like that. What's the probability of Fat scores a 215 or higher? No problem, okay? Remember what I want you guys to do. I want you to label the raw score, the z-score, and the percentile all the time. Okay, so his average is 200, and his standard deviation is 20, okay? And we want 215 or higher. So 215 is less than a deviation away. In fact, I'm going to do the numbers right here. It'll be 215 minus 200 divided by 20. And that z-score is, I believe, 0.75. Okay? So I'm going to put the z-score here. And then I'm going to make that a percentile. I'm going to shade it in. Okay? And please show all of that work. And so this is NCDF on your calculator or your table, 175 comma infinity, and that ends up being 0.2266. Okay? So that's our ability of Fat scoring 215 or higher. Pretty good chance of it, a little over 20%. All right. Question B. What are the chances Jose scores between 175 and 185? Okay, so we got a bracket on this. Same idea. Draw your curve, okay? Label your raw score, your z-score, and your percentile, okay? And Jose averages 190, okay? And his standard deviation is 15, a little bit different. He's more consistent. So between 175 and 185, right in there. Okay, this small window in here. Okay, so we got to get two z-scores for that. So I'm going to write that here: 175 minus 190 divided by 15. That's obviously a z-score of -1 there. And then the other one is 185 minus 190 divided by 15, and that is -0.33. So I want the area between those two z-scores. Both are negative because they are under the mean of 190. Okay, and I'm going to do NCDF -1 comma -0.33 on my calculator, which is probably the way you're going. You may be using the tables in the back of your book at this point, and that comes out it's a small area, 0.212, okay? About 21.2%, okay? All right, question C, using your answer from part A, okay? So on the AP test, this is common. What's the probability that Fat scores 215 or higher in 2 consecutive times? Consider the 2 games independent. If they're independent, that means you may multiply, okay? And the reason it says use your answer from part A is because even if you got part A wrong, you can get part C correct simply by doing the math right, and they'll show your work. So the probability of him scoring a 215 or higher was 0.2266, okay? And I'm simply going to square that for my answer of 0.0513, okay? And again, it doesn't really matter what you have in there. One of the strategies I tell kids is if you get A wrong, you know you got it wrong, or it left it blank, just put any number into part C and square it, and you'll get it right, okay? All right, now I got to scroll up for the other part for question 2. Okay, for question 2, the mean score for Fat is 200 with a standard deviation of 20. Jose, it's the same prompt. What is the probability that Fat and Jose combine for 400? Okay, now we're combining. So when you combine the means, you simply add them. So typically together, these guys are gonna score, let's see, 390, okay? Their standard deviation will be Pythagorean, which is 20 squared plus 15 squared, okay? Which comes out 25. I gave you a nice Pythagorean triple there, okay? And then what are the chances they score 400 or better? Well, 400 is pretty close there to the mean. 400 or better is probably going to be pretty common. That's my raw score, z-score, percentile. So to get my z-score for 400, I'm going to go 400 minus 390, and I'm going to divide that by 25. And that's going to come out 0.4. My z-score is going to be 0.4. Now, the area above that is pretty simple. I'm going to go NCDF 0.4 comma infinity, and I get an answer of 0.3446. Okay? All right. In part B is the head-to-head. What are the probability that Fat beats Jose? Okay, so this one is a little trickier for kids or everybody. Okay, set the same thing up. Now, what you want in the middle is their typical difference in a positive number. And their typical difference is 10. That is simply 200 minus 190. The standard deviation still combines in a Pythagorean method, so it's still 25. Okay? Now, all I'm going to do is identify 0, and 0 is the point always to the left here. That's where they tie. And you got to ask yourself, who's better, Fat or Jose? Because bowling is high score wins, Fat's better. Fat gets the larger side because he's going to win more often. And Jose gets the smaller size. And now all I do is calculate the z-score for 0. 0 represents a tie. Okay? So I'm going to go 0 minus 10 divided by 25. 0 minus 10 divided by 25, and I believe that is negative 0.4. So the z-score is negative 0.4. Okay? And then I'm going to figure out the area above that, which is going to be NCDF negative 0.4 comma infinity, and it's going to be well over 50%. It's 0.6554. That's the chances of Fat beating Jose. And that's it. One more note, when you get to quiz 6-2 and you have 4 people you got to combine, the standard deviations still combine a Pythagorean method. Square them all, add them up, and re-square root it. Good luck.